Welcome to the University of Adelaide's Electrical and Electronic Engineering 1A Impact Tutorial for Module 4, Part 1. Today I want to go through a quick discussion of pull-down resistors and why they're useful. Here we have an example circuit of a pull-down resistor. Now, a pull-down resistor is used in digital circuits to set a hard value of either 0 or 1 in digital terms. 1 in digital terms being positive 9 volts and 0 being ground. Without this pull-down resistor in place, what I've effectively got hanging off the end of this piece of wire up here is an antenna. Combine that with the internal model of the integrated circuit that I've just drawn here, which forms an RC network. These two are going to react, and if you manage to have some spurious radio noise coming past this small piece of wire or track that happens to be at this frequency that corresponds to this RC network, then you're going to see random voltages. It's going to vary between 9 volts and ground, up and down, up and down, up and down continuously. So you're not going to have a value, or you're not going to have a hard digital value set. In fact, quite often you can even get an input voltage on this device that's going to be higher than the rail voltage, and hence you might end up cooking the IC. All badness. So we want to avoid that situation. So one approach that could be taken is to tie this device directly to ground, not having a resistor there at all, as I've drawn. What happens in that instance though is when this switch is closed, we have a direct connection between our supply and ground. That's a dead short. So our old friend current equation equals V upon R equals 0, V is defined, the current tends to infinity. You're going to have low tracks or cooked wire, one of the two. Either way, your circuit's not going to work much longer. So instead, we need to limit the current flowing through that. The way we do that is with a resistor. Now, here I've drawn up a table of different resistors, and they're rough power calculations if we're going to use them in this instance. This is all according to the power rule, or the power equation I've got, V squared upon R. So I've assumed a 9 volt drop across this resistor. This is a 47 ohm resistor. I've lifted that straight out of module 2. And I'm also going to concern myself with all values up to about 10 meg ohm. Now, the trade-off becomes, down this low value resistor, have really large power consumption. Remember how big that power resistor had to be in module 2? Don't want that, because it pulls so much current. The other end of the spectrum, up at 10 meg, we had very, very little tiny current drawn. 1 microamp. Now that's not really measurable on any of our equipment. So low in fact, that effectively that resistor doesn't become there, it becomes an open circuit, and we revert back to the initial case of having this antenna up here. So we don't want that either. So a good trade-off is somewhere in the middle here. So typically, we're going to choose about 100k. It's large enough so that the power consumption is reduced, but small enough so that we don't contract back to this open circuit case and start having spurious values. Thank you.